Hello all, and thank you for watching another video from Ellensburg Amplifier Repair and Service here in Central Washington. Hopefully everything's coming through nice for you guys. I hope you all are enjoying your day, evening, or night. What I have today is I have two Taramps MD8Ks in for warranty repair. These are I think they're both the 1 ohm version. However, these both suffer the same fate. So, a common issue on these 8Ks, particularly the 8Ks, I see this the most on, are the complaint of the amplifier doesn't turn on, or doesn't turn on at all, doesn't do anything when they turn the remote on. So these two came from I think it's a competition rig that had 5 of them in the vehicle, and when they turned the vehicle on, 2 did not turn on. 2 of the 5. So they suffered the same fate, I should say. So the most common issue with this is right here, there's a little IC. It is a 8-pin IC. It's IC9, and it is a low dropout LDO voltage regulator. So when they apply the remote power here, it comes through, and this little IC here generates 5 volts for the rest of the circuit. This basically tells the amplifier, hey, let's get going, let's turn on and start things up. But a real common issue is these ICs fail. They short out. I don't know exactly what the cause is. I have been in discussion with Taramps on potential causes, but there's nothing definitive as to the reason why. So here's a little close-up shot of the area that I'm going to be working on with both amplifiers. So as you can see right here, IC9, there's a hole right in the top of that IC. And more often than not, there's 3 things you got to replace on this when this happens. You have to replace this IC, you have to replace this 4.7 ohm resistor, and this diode right here. This is a standard 4148 diode, 4.7 ohm resistor. I think this is a 1206 size resistor. And then, of course, IC9, which IC9 is going to be a somewhat expensive IC, as I like to point out a lot of things in today's component world. So you have the TPS 7A6601 IC here, and my current quote I just got either late last night or early this morning. When I opened my emails this morning, I got my quote for these. I think the quote was $35 each for this little remote IC. So I got 2 quotes, one for $50-something an IC, I think it was, and one for $35. So I mean, it just depends on which company you go through. They seem to all be doing their own price gouging in some way or another. It's really hard to find a company that won't tack on a huge price gouging percentage on these hard to get ICs. So that is what really builds the cost of repairing these. I've been talking with someone that has this exact same problem. I've told him, what needs to be replaced, the chip itself, and why it's so expensive to, do the job. This job here, I would charge you $75 to do this job. I have a $40 minimum. Plus, we got a $35 IC in here. So you can see where just a simple little IC here can, cost quite a bit to replace or repair. But overall, for the cost of the amplifier, $75 to get it back up and running is nothing compared to the actual overall cost of the board itself. So it's still, I believe, I run very fair, reasonable pricing on repairs. My goal is to help keep these things out of the ground. And of course, for warranty repairs, it's customer satisfaction all around between me, the service tech, and Taramps. So this kind of goes into both worlds of customer satisfaction and, of course, reduction of e-waste. So let's go ahead and get started. What I'm going to do first is I'm going to fire up the hot air gun here, the ST862D, and we're going to pull this IC and we're going to pull this diode out. This 4.7 ohm resistor did not suffer any damage to it. Sometimes you have to replace this, but most all times it's the IC and diode. I do have the ICs ready to go and the diodes ready to go. So we're just going to go ahead and remove this stuff and get started on this repair. And again, of course, if you guys have any questions, please feel free to leave them down below there for us, and I will get to as soon as I can. So hopefully you all can see what I see on the screen. I'm still working with this close-up. So I'm still trying to figure all that out. It's just as easy as that. Really simple process. Now, I should say simple as in, you know, people that do this often is simple. Reinstalling the IC can be substantially difficult if you're not used to changing out these little, what are these, these MSOP, I think they call this package. They are absolutely small. I mean, you can tell. There's the tweezers. There's my fingertip. So there's the size of that IC. So they're absolutely small. And soldering those in place can be substantially tricky. So let me get my new diode here. Again, this is the SMD 4148 diode. The goal is to not scoot any other components around while you're attempting this. Or allowing the diode to fly away from you. There we go. And of course, the diode has to be straight. So this is just tacking them in place. What I'm going to do is I'm going to add flux to this, and I'm going to hit it with the soldering iron. So now I'll get my IC out, and this is the same deal. These have a thermal pad on the bottom of the IC, as you can see right there, or not really because it's not focusing, but on the bottom of the IC there is a thermal pad. It says no, there we go, that you need to solder into place. So what I do is I solder that thermal pad down first, and then I go in with the soldering iron to solder the rest of the pins. So what I'll do is I'll just heat up that center pad. And I'll set the IC. In place. Straight, of course. So that sets the heat sink to it. We're going to add a little bit of flux here. Like good old Amtech flux. The IC into the diode. What I'm going to do is I'm going to come in and I'm going to follow it with some solder. One of the theories for the failure of these ICs is temperature. And in some amplifiers, when you solder components in place, you're actually adding a little bit of thermal mass to help dissipate heat that builds up in the circuit. Now for the IC, I have to put my helping eyes on so I can see what I'm doing, because these pins, again, are absolutely small and very close together. So you have to be really careful with the iron. And as you can see, I have two pins here, of course, that are bridged. But usually, you do enough of these, you don't really have a problem. With bridging, but of course I'm using a gigantic tip because my micro soldering station is at the other bench. So sometimes that's what makes making videos a little hard, because I have different tools at different benches. So what I'm going to do is I'm just going to reach right on down in here with some solder braid and pick it up quick and easy with some solder braid. And in my opinion, the trick with using that is to make sure you clean off the tip of the iron as much as possible, then reach in there with the solder braid, because that tip with no solder on it will help wick all that solder away. So now all the pins are clear. Bust out my trusty Q-tip and my isopropyl alcohol. And clean up the work. So you guys are probably wondering, man, if you charge $75 to do this, that's quite a bit. But what a lot of people don't know is the extra work I do to these boards to help prevent any future, I should say failures, any future failures of these boards. As most people know that watch my videos, the 8Ks and the 12Ks have particular issues. So one of the first things I do when I pop these covers off and I do my initial inspection or prep for estimate is I will take my glue and I will glue down the inductors. I don't know if you can see it, but I glued all these inductors down. They're solid as a rock now, because one of the failure points is these leads right here that do fail right at the board. The capacitors, I've glued all the capacitors down. I've glued this resistor down, this 10 ohm resistor. I've had resistors come in that are physically broke off the board or split in half, sometimes from heat. Again, that goes back to heat failures. And I glue all the filter capacitors down. So that's just the securing it components. The next most common failure for the 8Ks and the 12Ks are these traces at the transistors. So I already went through and I reinforced all the drain for the low side transistors. The traces, I've already reinforced them. And then the high side source traces burn out on these. So if you just reinforce the solder on the board, right where the trace bottlenecks to the leg of the transistor. I've had a few videos on this already now where they kind of pop open like a fuse. But if you lay your solder and kind of reflow, they have a section. I don't know, let me see if I can get you guys a picture of that section here. Let me scoot you on over here. Do we have somewhere that I can show you? Yes, there we go. So the area that I'm talking about is right here. From the factory, there's no solder here. No solder here. So what I do is I go through and I solder all the way up. I fill that spot, and it helps eliminate this bottleneck right here, because this bottleneck will open up like a fuse. So it really does help prevent the failure of the traces of this board by doing that. And then of course, for what I charge, I always do my load testing. It goes through full testing. If I do any work with the transistors or the drive ICs, I set DC offset. I do a lot of work behind the scenes that you guys really don't see here on camera. Otherwise, my videos would be long and boring, and I don't like making boring videos. I want to educate people, help them learn and understand that things like this can be repaired without having someone telling you you just got to buy a new amp. So that's my goal. My goal is to work for companies that I appreciate and they appreciate me, and my goal is to help keep amplifiers out of the ground. So that is the overall repair of the remote circuit for a Taramps MD8k. The IC, the diode, and sometimes you'll have to look closer, use your meter and check this 4.7 ohm resistor. That's usually the only things that fail when out of the blue these ICs fail. So again, there's no definitive answers, causes, or reasons why they're doing that. I have been in discussion with Taramps on solutions to this, but there's things coming down the pipe, things are in the plans and the works that are changing this design. But in the meantime, with these current boards that are out, we're just going to have to replace these ICs, think of different strategies on what's causing the failure. Possibly, I don't know if it is heat related, glue a heatsink to the top, kind of like the driver failures, the gate drive failures in ICs on some other boards due to heat. Or is it a load thing? Are people running their voltages too high Now remember, your remote turn-on voltage can be regulated or unregulated by your head unit. Some people wire the remote straight from the battery from a switch. Well, what if you're running a 17-volt system? Could be a little too high for the remote turn-on. So there's just a lot of different reasons why this particular issue exists, and I promise you guys I will work diligently to find solutions and answers on how to prevent this from happening. Again, you know, as a warranty repair, I have to replace part for part. And there's nothing I can change about the circuit itself. But hopefully one day I'll get my hands on an MD8k and start to experiment with I'm thinking about changing resistor values to limit inrush currents. That may or may not help, or by adding some form of heatsink if it is temperature related. So when I'm not busy, well, I don't know when that ever is, but when I'm not busy, I will find a way to help the current users of these Taramps MD8Ks and the 12Ks. So I do thank you guys for watching. If you have any comments, please leave them down below. I'm more than happy to help answer questions at any time. Please feel free, and always, as I say, stay safe, keep your fingers out of the rails. This stuff can really, really give you a bad day if you get tied up in the wrong thing. So I do thank you guys for watching. Please like and subscribe, like this content, and I will see you on the next one. Stay safe.